Welcome back, everyone. Today we're diving into a book that's, well, it's legendary in the world of mathematics. We're talking about Principia Mathematica, Volume 1, published way back in 1910.
Yeah,
Now,
1910.
I know what you might be thinking. 1910, that's over a century ago.
Right.
Why are we digging into something so old?
Right.
Especially a book about mathematics, a field that's all about, new discoveries and pushing the boundaries. But trust me on this one. This book, it's like the granddaddy of foundational math. It still has ripples that reach us even today.
Oh, absolutely.
So today we're going to unpack Principia Mathematica, figure out what its core ideas were, why it was so revolutionary, and maybe even why it still matters even in our modern world. What do you say? Ready to take the plunge?
Let's do it.
Yeah.
It's fascinating stuff, really. See, before Principia Mathematica came along, math relied a lot on intuition, like what seems obvious.
Right.
But Whitehead and Russell, the authors, they wanted something different. They wanted a system where every single mathematical truth, every theorem could be built up step by step, logically, from a small set of undeniable basic principles. They weren't satisfied with just knowing something, they wanted to prove it absolutely rock solid.
Okay, I got to be honest, that sounds crazy ambitious. Who were these guys, Whitehead and Russell? What made them think they could pull this off?
Well, Whitehead, he was a philosopher and a mathematician, really into exploring the deep philosophical underpinnings of math. He'd been doing it for quite a while before Principia, actually. And Russell, he was on the same wavelength, especially concerned with making sure mathematics was logically sound. Together, they were a force to be reckoned with, ready to tackle one of the biggest questions in mathematics. Can you build the whole system, the whole shebang, from scratch, using just logic?
And Principia Mathematica was their answer to that question?
Yeah.
It wasn't just some side project either, right? I mean, they divided this thing into 3 massive volumes, each one tackling a different part of mathematics. It's like they were laying a new foundation for the entire field.
That's exactly it. They were going for a total system overhaul. Volume 1, that's our focus today, dives into the really fundamental stuff. Mathematical logic, set theory, the building blocks. Then they plan to tackle real numbers in Volume 2, and then geometry and measurement in Volume 3. The whole 9 yards.
Wow. Okay, so it was meant to be, comprehensive, completely airtight.
Absolutely, yeah.
Okay, I'm starting to see why this book is such a big deal, but I want to get into the nitty-gritty here. One thing that always kind of scared me away from Principia, I got to be honest, was all the symbols. Pages and pages of symbols.
Yeah.
It's intimidating. It feels like trying to read hieroglyphics sometimes. Was that intentional? Were they just trying to make it harder on us?
I think it was, well, a little both, to be honest. Remember, they really wanted to avoid any of the vagueness or ambiguity of everyday language.
Okay.
They wanted absolute precision. So they developed this symbolic logic system where each symbol, every little squiggle, has a very specific logical operation or relationship it represents.
Like their own secret code.
Kind of. But the goal wasn't to be secretive, really. It was to be incredibly, incredibly precise.
Right, it's about clarity.
Exactly. They were creating a universal language for math, free from all the misinterpretations that come with our normal words.
That makes sense. So tell me a bit more about this symbolic logic. How does it work? What did they see as the fundamental building blocks?
That's where the primitive propositions come in.
Primitive propositions. Okay.
Yeah, think of them as the bedrock. These are statements, super basic, that they considered so obviously true they didn't need any further proof, like axioms in geometry.
Primitive propositions. So self-evident truths.
Exactly.
And from these, what did they do? They tried to build up the entire structure of mathematics, right?
Yeah, they wanted to show that from these simple starting points, you could logically deduce everything else.
It's mind-boggling.
Yeah.
But how'd they actually do it? What were the tools? What did they build with?
Well, it was a combination of things, like rigorous logical deduction, which we've talked about, but also this symbolic language they developed specifically for Principia.
Right.
And one of the really cool things they did was they used this symbol. It looks like this. I can't really show it to you. But imagine it's like a horizontal line with a vertical line on the left end.
Okay, I think I can picture that.
It's called a turnstile. And it's a simple symbol, but it represents a really big shift in how we think about, the relationships between different mathematical statements.
I've got to admit, those symbols are what always intimidated me about Principia. What does that one mean exactly? What were they trying to get at?
Well, the turnstile symbol, it basically means implies,
Okay.
but it's implies with a much stricter, more formal meaning than how we usually use the word. It's not just about how we use implies in everyday language. It's a very precise way of saying, if this statement is true, then this other statement, it must also be true.
So, like, there's no wiggle room.
Exactly. No wiggle room. It's about that unavoidable logical flow from one proposition to another.
So they're capturing, like, the essence of logical deduction in a pure, like, symbolic form.
Precisely.
No more wishy-washy human intuition.
Yeah.
But did they manage to actually build up all of mathematics using this super rigorous symbolic approach?
That's the million-dollar question, isn't it? And it's where things get really interesting. You see, as groundbreaking as Principia Mathematica was, their quest to find a complete and consistent system for all of mathematics, it hit a snag.
You're talking about Gödel's incompleteness theorems, right?
Exactly.
I've heard about these earth-shattering theorems shaking the foundations of mathematics. What were they all about? What did Gödel do?
Okay, so imagine this. It's the 1930s. Kurt Gödel, this brilliant logician, he comes along and he proves something truly remarkable. He shows that within any formal system, any system at all that's powerful enough to encompass basic arithmetic, like the one Whitehead and Russell were building, there will always be some statements, mathematical statements that are true, demonstrably true.
Okay.
But you can't actually prove them within that system.
Whoa.
Yeah, it's a real head spinner.
So even with all their effort, all their meticulous logic, their symbols, Principia Mathematica couldn't achieve that ultimate goal, that complete and consistent system they were striving for.
Sadly, that's the implication of Gödel's work.
That's a pretty significant limitation, isn't it?
It was a paradigm shift, there's no doubt about it. It really challenged the core assumptions of what people thought mathematics was. But here's the thing. Even though Principia Mathematica couldn't achieve absolute completeness, it still had this undeniable impact.
Really?
Oh, absolutely. It fundamentally shifted the way we think about math.
That's what I find so fascinating. You know, we're talking about a book that's over a century old.
I know.
And in a way, it was, what you're saying is it was kind of incomplete.
Yeah.
But it's still considered so important today. Why is that?
That is the question, isn't it? It's a great one. Okay, imagine this. You're an astronomer.
Right.
But you're an astronomer before the invention of the telescope.
I like where this is going.
So you can observe the stars, you can chart their movements, but your understanding, it's limited by what you can see with naked eye.
Right.
And then boom, the telescope is invented.
That's your evolution.
Totally. Now, the telescope, it doesn't answer every question about the universe, not at all. But it fundamentally changes how you study it. It opens up all these new possibilities, new avenues of exploration, new questions.
So you're saying that Principia Mathematica, it was like a telescope for mathematics.
Exactly. It provided a new lens, a new way of seeing and understanding mathematical concepts. And those things, the focus on rigorous proofs, the use of symbolic logic, those became central to how math was done from that point forward.
So even if Principia Mathematica didn't achieve, like, the ultimate goal, it opened up these entirely new ways of thinking about and doing mathematics.
Yes. And it's that legacy, those new perspectives and methods that make it so important.
It's amazing, isn't it, how a book with this, like, laser focus on the foundations of mathematics could end up having this huge impact on how we think about, well, everything.
Yeah, it's not just about the specific results, is it? It's more about the approach they took, that dedication to really building a system on solid logic. And that's powerful stuff.
It makes you wonder, could we apply this kind of thinking to other fields?
That's the million-dollar question. What if we tried to approach ethics or economics, even political science, with that same rigor?
It's a wild thought.
Totally.
Yeah.
Like, imagine trying to define the primitive propositions of human behavior or economic systems.
I mean, I know we can't just take mathematical formulas and apply them to people, can we?
Probably not. But the underlying principle, breaking down these really complex systems into their most basic parts and building back up logically, that's got potential, doesn't it?
Yeah, it does.
Of course, it wouldn't be easy. Every field has its own, quirks and challenges. But that spirit of Principia Mathematica, the emphasis on clear definitions, logical reasoning, and really going for consistency, that's something we could all use a bit more of.
It's like Principia Mathematica as a call to action or something, a reminder that even the most complicated systems, even the ones that involve human behavior, we can understand them better
Hmm.
if we approach them with, like, intellectual honesty, clarity, and a willingness to question our assumptions.
Absolutely. And who knows what we might discover if we do that? What breakthroughs are waiting for us if we just dare to think that way?
It's pretty inspiring when you put it like that. Well, I think that about wraps up our deep dive into the world of Principia Mathematica. This book, it's more than just some dusty old tome. It's like this living testament to the power of human reason, a real inspiration for anyone trying to make sense of the world.
Couldn't have said it better myself. It reminds us that even when we shoot for the stars and maybe don't quite get there, the journey itself can lead to some amazing discoveries.
And that's what it's all about, right? The journey of discovery. Thanks for joining us, everyone, and until next time, keep those brains buzzing.